Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is 5.3, Function Rules, Tables, and Graphs. Today we're going to be looking at, day 2, I'm sorry. Today we're going to be looking at graphing functions using a table. We need to graph each function by making a smart table of values. I'll explain what that means here in 1 second. What we really want to look at is the difference between absolute value graphs, quadratic formula graphs, linear graphs, and that's it, actually, those three things. All right. So the first thing I want to do is go ahead and characterize what each one of these graphs is going to be. How I do that is I look at the pieces of information in the equation. The first one that you see there, the first arrow I drew, let me get rid of this arrow for you. The first arrow I drew is pointing at what? What are those two vertical lines in that problem? Well, that is the absolute value. Okay? Actually, again, I apologize. Let me write that up here. This is going to be an absolute value equation. Jeez. The second graph we're looking at is going to be, that is known as a quadratic graph. If it is squared, if you ever see a variable squared, that is a quadratic graph. I'm sorry, if the largest exponent in the equation is squared, then that is going to be a quadratic graph. Let's look down here at number 2. That is also, what is the two bars, two vertical bars? Absolute value. Now, if my x does not have an exponent, then this is going to be a linear graph. We'll talk about what happens with each one of those here in 1 second. Number 3, again, I have a quadratic. And 4, again, my x does not have a variable, or does not have an exponent, so it will be a linear graph. Okay? Now, let's talk about what each one of these graphs should look like. When I have an absolute value, it's going to look like a V. When I get done, it should look just like a V. And you'll see that here in 1 second. If I have a quadratic formula graph, it's going to look kind of like a U. All right? All right? Number 2, absolute value, should be a V. Linear is going to be a straight line. We're going to have a straight line. Okay? Down here we have another quadratic, so that should be a U. And the last one, linear, should be another straight line. Okay? So let's talk about what a smart table of values is. This V that you're looking at, it's going to split a graph perfectly down the middle. Okay? The U is also going to split a graph. So our V's and our U's are going to split a graph. What we want to do is we want to make sure that our V and our U's are perfectly split. So I need some values on the left side of something, some values on the right side of something. So in order to make sure of that, I'm going to put 0 right in the middle. I'm going to put 1 to the right, 2 to the right. Negative 1 to the left, negative 2 to the left. Remember, this is your X, this is your Y. So now what I have to do is I'm going to have to solve my equation for Y in order to make sure that my graph splits right at 0. Okay? So what I'm going to do is I'm going to take the equation, y equals the absolute value. I'm going to use each one of these x values and plug it in for x to find my y values. So the first one we come across is negative 2. So we'll take the absolute value of negative 2, which is positive 2, minus 2, which will equal 0. So my y value would be 0. Now I want to take y equals the absolute value of negative 1 minus 2, The absolute value of negative 1 is 1. Subtract 2, I get negative 1. All right. Next one is y equals the absolute value of 0 minus 2. So that will equal 0 minus 2, which is negative 2. I need to put 1 in for x as well, so y equals the absolute value of 1 minus 2, which would be 1 minus 2 again, which equals negative 1. Notice that the 2 points that are closest to the center are actually the same. So I have a negative 1 here, and I have a negative 1 there. Let's see if that happens again for the 2 points that are further away from the center. So if I do y is equal to the absolute value of positive 2 minus 2, I get 2 minus 2, which is in fact 0. Guys, that is going to happen with every single graph you do when you have the absolute value or a quadratic. So really all I have to do is fill in 1/2 of the graph and I'll know what the y values are on the other side. Okay? Let's go ahead and check out the quadratic in number 4 then real quick. Remember, I want to use a smart graph or a smart table of values. In order to use a smart table of values, again, I'm going to put 0 in the center, 1 to the right, 2 to the right, negative 1 to the left, negative 2 to the left. Okay? So if I have 0, so my f of 0 is going to equal 0 squared plus 1. I'm just putting 0 in for all the x's. 0 plus 1 would equal 1. So when my when my x value is 0, my y or my f of x is going to be 1. How about if I put 1 in for all the x's? I'd have 1 squared plus 1, which equals 1 plus 1, which will equal 2. F of 2 should be 2 squared plus 1 will equal 4 plus 1, which equals 5. Now, if you do not believe me that this number and this number should be the same, go ahead and type in your calculator parenthesis negative 1 parenthesis squared plus 1. What you're going to find is negative 1 squared is actually positive 1. 1 plus 1 will be 2. You're going to find that negative 2 squared is going to be 4. 4 plus 1 is 5. So again, all I have to do is fill in the 2 points to the right of my center in my y values, and the 2 points to the left are going to mirror them. Okay? So on down here to number 2. I'm going to do an absolute value. So remember the smart graph. 0, 1, 2, negative 1, negative 2. If I put 0 in for x, my y would equal the absolute value of 3 times 0, which is the absolute value of 0, which is in fact 0. If I put 1 in for x, it would be the absolute value of 3 times 1, which is the absolute value of 3, which would be 3. If I put 2 in for x, it would be the absolute value of 3 times 2, which would equal the absolute value of 6, which is also 6. Now that I've filled in the right side of my graph, I can fill in the left side of my graph. Remember that the 2 points that are closest to the center are going to work together, so 3 and 3. The 2 outer points are going to work together, so 6 and 6. On to number 5. Linear is not going to work exactly the same. Okay? This is really where your smart graph will come into play. I do not want to have decimals. I do not want to have decimals. So what I'm going to do is I will put 0 in the center still. Instead of going plus 1 to move to the right, what I'm going to do is I'm going to increase my x values by the denominator. So here I'm going to add 2, give me 2. I'll add 2, that'll give me 4. Going to the left, I want the other side of my y-axis. So I will subtract 2, which would get me negative 2. Subtract 2, which would get me negative 4. Notice that I'm counting by 2's because my denominator is 2. So now what I'm going to do is I'm going to put in 0 for x, so 1/2 times 0 plus 5 would equal 0 plus 5, which is 5. I'll put 2 in for x. 1/2 times 2 plus 5 would equal 1 plus 5, which equals 6. If I put 4 in for x, it'd be 1/2 times 4 plus 5. 2 plus 5 would equal 7. All right. This is not going to work the same way as your absolute value in your quadratic. This point here and this value here are not going to be the same in this situation. That only works for a quadratic and an absolute value. So I need to continue with my negatives. So it would be y equals 1/2 times -2 plus 5. That would get me -1 plus 5, which would equal 4. But hopefully you've noticed a pattern. My y's are moving by 1, right? Let's see if that holds true here. 1 over 2 times -4 plus 5. That would get me -2 plus 5, which equals 3. Would moving up by 1 every time that my x's move up by 2 get me a straight line? Yes, it will. So that makes sense with our linear graph, knowing that it's supposed to be a straight line. All right? Let's go down to number 3 here. Another quadratic. So with a quadratic, I'll use 0, 1, 2, -1, -2. I'll move my x's by 1. If I put 0 in for x, f of 0 will equal 1 minus 0 squared, which will equal 1 minus 0, which is 1. F of 1 will equal 1 minus 1 squared, which is 1 minus 1, which is 0. And f of 2 will equal 1 minus 2 squared, which is 1 minus 4, which would be -3. Okay? Again, this is a quadratic. So this point and this point will work together. So that's 0 as well. This point and this point will work together. So that would be -3. Both sides of a quadratic and an absolute value are mirror images of each other. On to number 6. We talked about just a second ago that if I have a linear table, I'm still going to start with 0 in the center. But I'm going to move up and I'm going to move down by my denominator. So I'm going to move up by 3's, so it'll be 3 and 6. I'm going to move down by 3's, so -3, -6. If I put 0 in for x, it would be y equals 2 over 3 times 0 minus 7, which would be 0 minus 7. So my y at x being 0 would be -7. If I put 3 in for x, it'd be 2 over 3 times 3 minus 7. 2 over 3 times 3 just means that these are going to cancel. So I'll have 2 minus 7, which equals -5. If I put 6 in for x, it'd be 2 over 3 times 6 minus 7, which would equal, if I take 2 times 6, that's 12. 12 divided by 3 is going to get me 4. So 4 minus 7 would be -3. Continue, because it's linear, I know that it will not be mirrored. I'll have y equals 2 over 3 times -3 minus 7. These are going to cancel again, but only the 3's are going to cancel. So I'm really going to have 2 times -1. So it'd be -2 minus 7 would equal -9. Then y equals 2 over 3 times -6 minus 7. 2 times -6 is going to get me -12. -12 divided by 3 would be -4. -4 minus 7 is -11. Okay? So now that we have made our tables, what we're going to do is we're going to graph them. So let's go ahead and move on and start graphing them. This is going to be problem number 1. If you remember from what we just did with our tables, problem number 1 was an absolute value. Okay? The first point, the center point of our absolute value was 0, -2. So we have a point at 0, -2. Then we had 1, -1. Then we had 2, 0. So that's the right leg of our absolute value graph. The left leg, I would have -1, -1, and -2, 0. Okay? It already pretty much resembles a V. The only thing I have to do now is I have to connect the points. All of these graphs are going to have arrows pointing out, and it does resemble a V, so we're absolutely good. Knowing that absolute value should resemble a V, we know we're going to be good. Let's go ahead and graph number 2 here. Again, this should be an absolute value. Since it's an absolute value, I know I'm going to have a V graph. My first point was at 0, 0. Then I went 1, +3. And I went 2, +6. So 4, 5, 6. Okay? And then I went -1, +3. -2, +6. Since you know that it should be mirrored, all I would have to do, instead of actually counting out everything, once I have the right leg of my graph done, I can just come over to the left, keep it at the same height as what I have here, bring it over to the left to -1 on my x-axis, bring the same height from here over to -2 on my x-axis, and I will be done. Make sure that it looks like a V. Do not round the bottom. If you round the bottom, then it'll look like a U, and you would have made a quadratic graph. All right? Let's move on to number 3. Number 3. In number 3, I had a quadratic, so this should look like a U. The first point on my quadratic table was 0, 1. Then I had 1, 0. Then I had 2, -3. Again, because I have the right leg written, all I have to do is go to the point that is 1 on my x-axis, move it over to -1 on my y-axis. I have to go to the point that is +2 on my x-axis, move it over to -2 on my y-axis, and I am done. From here, just connect our points, make sure that it rounds at the vertex or the top point there, and it looks fairly similar to an upside down U. On to number 4. Number 4, it says in our table, I have 0, 1. I had 1, 2. I had 2, 5. Again, I can just mirror it, so this would be here. That would be there. Connect my points, make sure it's rounded at the bottom, and I have what looks very similar to a U. Pretty simple graphing points, guys. All you have to do is go right to left with your x values, up and down with your y values. Okay? On to number 5. Now we have a linear graph. This needs to be a straight line. So in my on number 5 in my table, the middle point was 0, 5. So 0 is here on the x-axis. 5 is 1, 2, 3, 4, 5. I go to 1 on my x-axis. I need to go up to 2. So 1, 2. I have 2 on my x-axis, which is here. Whoops. I screwed that up. I'm sorry. Again, though, it would be 0, then 1, 2, 3, 4, 5. Then I go to 2, up to 1, 2, 3, 4, 5, 6. Then I can go to 4, 1, 2, 3, 4, 5, 6, 7. Okay? Let me get rid of those smaller points so that you're not confused. I'm just showing you how I'm counting this right now. Going back the other way, I go to -2. So this is 0, -1, -2. From -2, I go up 4. 1, 2, 3, 4. Then I go to -4. So -1, -2, -3, -4. From there, I'm going to count up 3. 1, 2, 3. Now, as you can see, this looks like they are all aligned. They're in a straight line. So what I want to do is draw a straight line to graph it, and I am done. Okay? On to number 6, another linear graph, so it should be a straight line. My first point was x was 0, y was -7. So 1, 2, 3, 4, 5, 6, 7. There's a point there. I was moving by 3, so I need to go right 3. 1, 2, 3. And I will go down 5. 1, 2, 3, 4, 5. Then I need to go to 6. This was 3, so 4, 5, 6. You go down to 3. 1, 2, 3. Okay? Going the opposite direction, the left side of my graph, I need to go to -3, so 1, 2, 3. And down to -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Make a point there. Then I need to go to -6. This is -4, -5, -6, down to 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And I'll make a point there. Yes, that's off the graph, so just do your best if your final point ends up off the graph. I'm going to get rid of these little points here so we can see our straight-ish line at this point. Make sure that if you have a flat edge, you go ahead and use that. So that is the end of our lesson. What we learned today is how to use a smart table of values. That an absolute value graph is going to look like a V, a quadratic graph is going to look like a U, and a linear graph, which makes sense because the word line is already in there, is going to look like a straight line. We also learned that the right side and left side of a absolute value graph or a quadratic graph is going to be mirrored, and that if I have a linear graph, which means that my x is not raised to any power, that I want to move my x's by the denominator inside of my equation. All right. Well, thank you very much for watching this video. Make sure that if you have any questions, you bring them to me tomorrow, and have a great day.